welcome. So we're going to build a Raspberry Pi and get Bitcoin running on it. All right, so in this episode, we are going to be looking at the Raspberry Pi 4 with 8 gigs of RAM. So I just got this from CanaKit, and I'm going to be putting it together from scratch. I also got a 1 terabyte USB drive that is an SSD, so it should be pretty fast. And so I'm just going to be putting it together and getting it up and running. So basically just putting all of the heat sinks on, putting it into the case, connecting everything up, getting the fan on. The only weird thing was I couldn't figure out which way the fan would blow, but we'll talk about that a little bit later. And so here it is all completed and everything's good to go. We've got the ports, power cord. The power cord came with a little on-off switch, which seemed pretty nice. Nice on-off switch there. And we've got the little USB SSD here that is powered through the USB. All right, so we are going to be installing Raspberry Pi OS. One thing I wanted to check out was the 64-bit version of the OS instead of doing the default 32. So the Raspberry Pi 4 I have has 8 gigs of RAM in it, and I want to be able to utilize all of that, so I need a 64-bit OS. The 64-bit OS is still under beta, but you can find it online, and there's a link to download it. I've downloaded the zip file here. I'm going to unzip it. And the other thing is you need to do is run the Raspberry Pi imager, which is, there's a link on this forum page as well. All right, so the next step I need to do is just choose the OS and the SD card. So for OS, I'm going to use a custom one. I'm going to choose the one that I downloaded. I'm going to give it that. And for the SD card, I've got the SD card plugged in here, so we can see that. And I'm just going to kick this off. All right, so the SD card has been reformatted with the new OS, so I'm going to take it out and put it into the Raspberry Pi, and we'll get that. Okay, so I got the OS installed onto the SD card, rebooted it a couple times, and what I'm not showing you here is the process to set your password, time zone, and a few things when you first log into the Pi. The other thing I did was I enabled SSH on the Pi so that I can use my desktop here and get to it. And to do that, all you have to do is just go into your preferences, under the Pi configuration, and set the SSH to enable, and you should be good to go. All right, so I've SSH'd in here, and we are going to poke around, and the goal is to get Bitcoin installed and running here. There are a couple tools that I like to use, so I'm going to get those installed. One is PyDF here, and so we're going to install that one. This one allows you to get sort of a visual view of your disk space running on the device. So for example, you can run PyDF here. We can see that there's 3 file systems. The other thing you can see down here is my USB drive, external USB drive is mounted, but we're going to format that and clear it all from everything that's on it anyways, and so we'll do that in a minute here. The other thing I want to add is HTOP. So this tool, in case you don't know, will show you a picture of your process usage. And so across the top here, you see the cores. So it's got 4 cores on this Raspberry Pi 4. It's got the memory. So you can see that it's showing it's got 8 gigs here, and only a small percentage of that's being used. So this is everything that's running on the system right now, and we can pop in here if we want to see how things are running. The last thing we want to install is Screen. So I like to use that to just have stuff run in the background in case I need to exit out of the shell and let it keep running. One other interesting thing you can do on the Raspberry Pi is to view the temperature. So there's a command here, vcgen command, measure temp, and that will give you the CPU. So when we start cranking through some stuff, I'm going to play around and see what the CPU looks like. On the device I got, I'm just using the exact same setup that came with the CanaKit. The CPU fan that it has on top seems a little weird because the Raspberry Pi logo is the only air inlet. So I'm curious to see once we start compiling stuff how the CPU temperature holds up compared to that. Okay, the first thing we want to do here is to format the external Samsung 1 terabyte drive that I have attached, and then get it mounted permanently to a location that I can actually remember. Okay, so the first thing we want to do is get this disk reformatted. So I have the 1 terabyte Samsung attached to the USB, And we can see it's already been auto-mounted using crazy label here, which makes no sense to me. So we're going to try to unmount it first. And let's double check that. Okay, it's gone. And so now the next thing we want to do is try and figure out which disk, where that disk is located. I'm going to run sudo. Okay, so the one that we want to handle here is the dev SDA. And what we're going to do here is we're going to run the makefs ext4 on that device. So let's give that a try here. Okay, so it's all done. Writing super block. Okay, great. And we want to, let's give it a label just to make it very clear going forward. So there's command E2. And we'll call this Samsung. All right, and you can see that it's still not here. Let's just do the command that we did before to look here. So you can see it's there, good to go. And the last thing we want to do is to mount it and try to mount it permanently so that we can remember where it is. So if we look under media, and let's see what's under there. So the Pi one is there by default. There's nothing in it. I'm going to do a new directory under media and just call it Samsung and just keep everything same. Great. So now if we look under media, we should see that drive there. Let's just do that. Great. So the next thing that we're going to do is we need to mount it. So I'm going to do sudo mount dev SDA, and I'm going to point it at that directory, media Samsung. Now if we look at media Samsung, we can see that there's some stuff there, lost and found there. And so the last thing we want to do is make this so it remounts it at boot time. And so we're going to look at the FS tab. All right, so from here, we need to get the UUID of the disk. And so let's do sudo ls al dev disk by UUID. There we go. All right, so we need to copy the UUID for this disk here, and then we will use Vim to get into this tab. And so over here, we are going to put UID equals that, and we want it to go to /media/Samsung, and we're going to do ext4 and defaults and 0 and 0. And we'll save that, and then we'll test it out. Right, didn't blow up, so then we're good to go. So we can reboot, and hopefully that will show up correctly. So we'll do that right now, and we'll check back in a second. Okay, so once the reboot happens, we're back in, and so now we should be able to see that it got auto-mounted correctly, media Samsung, and we're good to go. So there's the disk there. If we look at PDF, we can see that dev SDA there, and it's mounted to media Samsung, and so that should be good to go. And we've got 869 gigs to play with here. And so the next thing we're going to do is get Bitcoin up and running, and we're going to compile it from source. All right, so to get Bitcoin compiled and running on your local machine, we're going to start with the GitHub repository here. And under doc, there is the instructions on how to build this stuff. And we're going to go under the Unix one and take a look there. And so this has the instructions for everything, for how to run through it all the dependencies you need. We're going to just build it so that we can run Lightning. So we're going to need a few things that might not be installed by default. We're going to want the 0MQ or ZMQ package built. I'm just going to go ahead and build it for everything, including the GUI. I'm not going to use the GUI, but I figured might as well just see how that compiles and just make sure everything works. Okay, so the first thing we're going to do is get source code down from GitHub. And if you remember, if we look at the disks here with IDF, we can see that I've got the big media Samsung disk here. It's got 869 gigs free. And so I want to do everything there. It's also an SSD, so it's going to be faster than the SD card probably. And SD cards, degrade over time. So just for this setup, I'm going to use that for all of the files and source code and building that I'm going to be doing. So I'm going to switch over to that directory, and if I do, uh, ls on the slash media directory, we're going to see that it's owned by the root account, and so I don't want to have to do sudo for everything that I'm going to do here. So I'm going to change the ownership of Pi to Pi on media Samsung, and if we do that ls again, we can see that Pi is now the guy. So here now I can, since I own the directory, I can make the directory and just call it source. I'm going to go into source, and the first thing we need to do is get the source code from the Bitcoin repository. So I'm just going to clone this down with git, and once that's down here, we'll start getting building. Okay, once we have all of the source code down, we can see that the Bitcoin directory is there. So I'm going to go into that one. And if we do a git status, we can see that we're on the master branch. So the master branch is the absolute latest. And so we don't want that. We want to actually use the release. And so we're just going to use the last release, which is 021. And to do that, we can just git check out the tags for that version, or the tag for that specific version. And so now we are on that specific version, and we should be good to go. So the next thing we need to do is to get the dependencies. So Bitcoin requires a bunch of third-party dependencies. There's this depends folder here, and you can either just install the packages through your system, or you can rebuild everything locally. So I'm just going to rebuild everything from scratch just to go through that process and make sure everything works. And to do that, basically we just need to go into the depends folder and run make here. So we're going to go into depends, and we're going to run make. One thing is, if you just run make default, a lot of times it will just run with one core on the system. The other thing is that I don't want to have to sit here and keep this session open while it's building. I want to be able to look at other stuff and have other sessions going. So the first thing I'm going to do is I'm going to create a screen, and I'm just going to call it Bitcoin. And so now we're in Bitcoin, and you can't see me typing, but if I hit Control A, then D, it jumps back here. And so this is how you can detach from different screens, and I can go back into it by running screen -X and Bitcoin, and then I'm back in the other session that I'm at. And so I can create as many of these as I want, not have to have separate SSH sessions. And even if I bail out of the SSH completely, it'll keep running. All right. So what we're going to do here is we're going to run make. One thing though is we don't want to run just against one core on the CPU, so I'm going to tell it the jobs I want to run is 6. And the reason I'm choosing 6 is because there's 4 cores on the Pi, and the rule of thumb is to use 1.5 the amount of cores, so that even if one of those cores is waiting for disk I/O, another core can be doing some work. So we're going to kick this off, and it might take a while. All right, so here's where we can sort of show off the screen setup that I'm doing. And so we're building, everything's running. If I hit Control A, D, it drops me back to the main screen that I was at before. And so we can do screen ls, and we can see that the Bitcoin screen is running, and we're detached from it. And so I can exit out of this SSH session, and that will continue building, so I don't need to worry about that dropping. And then I can also do things like check out what's going on the system while that's building. We can see that it's doing something. At this point, one of the CPUs is getting pegged out, or the CPU cores, and so we will see how that does. And I ran into the first problem. So one thing I forgot to do when I was looking at the instructions is you do need a set of initial packages to support the build. And so I need to install that first. The previous one bailed out after it couldn't find the auto make tool. And so once this is done, then we're going to go back and we're going to run this make command again, and we should have better success this time. All right, so the build is complete, and a few times while it was running, I was just sort of poking around to see what the temperature was. Got up to 53°C. I think the operating range is up to 70 degrees Celsius, so nothing too crazy. Obviously, the lower the better. After it's done now, if I run it again, we're back down in the 30s, and so this is probably more what we hope it stays in once we get done with all this crunching in the building. So. That took probably about 40 minutes or so. Everything's done, and we can hop back into the Bitcoin screen here and see that this is done too. So the next thing we need to do is to actually get the Bitcoin to build, right? So we've got all of the dependencies, we've got all the GUI dependencies, we've got all the 0MQ dependencies. So everything should be there. The Berkeley DB dependency is the big one. And so the next thing, we just need to go kick off the actual build steps. So we're going to go back into the top level source directory into the Bitcoin directory where the source is, and we're going to take a look at these commands here. So the first one is Autogen, and we're just going to run these in order. And again, when I run the make command, I'm going to tell it to run with 6 jobs. All right, so I ran into my second problem here, and that's when I ran the configure command, it gave me an error about not finding stuff. And so I jumped back in, and if you take a look at the depends folder that we were looking at, the README in there, so we're under Bitcoin depends, it says by default, when you run the configure command, it's going to ignore all the stuff that you built for it to use, and so you have to use this prefix so that it knows what to do. So we can see here that if we do an ls on the depends folder, we can see that it built the Linux GNU here. So we're going to run configure, and we're going to tell it to look here. And so hopefully this time it will work. Okay, so that worked that time by running the configure with the pointer to the dependencies that we built. And so the next is to run make, and again, I'm going to tell it to run 6 jobs. And so this is going to take another step that's going to take a little while to complete.
All right, so one thing that I thought might be interesting to take a look at is the temperature for this case. So you can see that this case, it's got like this little black, see if I can do this with one hand here, but it's got this black cover on it, and the only airflow for the fan is through this little Raspberry Pi vent there. And I looked online, and a couple people said that, pulling the sucking the heat out actually is less efficient than blowing cool air in from the top. And then also, this thing doesn't let very much air through. You can see the air vents are covered mostly by the middle of that fan where the little motor is. So one other thing that I sort of did as well, and I'll show you in a second here, is that I also took it and propped open the case and just set the fan up so it's blowing directly onto the heat sinks there. While I was doing that, I've got the temperature being monitored on the screen over on the side, and when I pulled the fan off, it went immediately up to 59 degrees Celsius. So the interesting thing is, so pulling air out of the case with this fan and the case completely together, the temperature while compiling is about 54 degrees Celsius. If I flip the fan around and blow into the case, it drops it to 53 degrees Celsius. And then if I do this sort of setup where it's just pointing directly at the heat sinks and with the top off completely, it'll drop down to about 49 degrees Celsius. So interesting heating issues with this thing, and while it's actually cranking and doing a lot of work. And it might be interesting to build or maybe 3D print a custom case that actually can put a decent fan and also better ventilation in there.
All right, so that build is complete. Everything worked that time. And so the last thing we're going to do here on this sort of front is do sudo make install so that it installs the binaries into the correct locations. All right, so I'm hitting problem number 3 here. So an interesting thing that I did, so the build finished, everything's good to go. Run sudo make install. Usually this copies stuff to the bin directory for you. but for some reason I'm not able to get that to work here. So if I say which Bitcoin D, it doesn't know about it. So I'm a little confused about that, but what I'm going to do instead is just move forward and just try to get this to run anyways. One thing I need to do is to make sure that when we start Bitcoin D up, that it puts the blockchain data onto the Samsung USB drive instead of trying to put it locally. So I'm going to go into my home directory. I'm going to make a .bitcoin directory. I'm going to go into there, and I'm going to do a bitcoin.conf. And before I do that, basically I want to put the data directory under here. So there's only a source directory there, so I'm gonna make dir media Samsung, and we'll just call it Bitcoin data, or maybe we'll just call it data. And so that'll be there, and I'm just going to copy that, and so /media data, and then I'm going to do vim bitcoin.conf, and I'm going to put the data dir equals media Samsung, and what do we say, data, right? So when Bitcoin D starts up, it's going to look in this directory for this bitcoin.conf file. It'll find that, it'll see the data dir, and it will trigger the all the data and all the blockchain to be put under that directory. So let's give this a try. So I'm just going to run media Samsung source Bitcoin, and then it's source again, and then Bitcoin D. And so we're going to see if this works correctly. So it looks like it's running. That's good. And we'll let it run a little bit, and then once it starts syncing, I'm going to kill it and just make sure that the everything looks okay. All right, so we're synchronizing block headers. Okay, so I'm going to kill it, whatever. Let's just do a ls in the .bitcoin directory, make sure it didn't put stuff there. So that looks good. And then if I go to the media Samsung data, and I do an ls in here, we can see all the chain state, everything is there. So I'm going to go back into the screen that I had before. I think it's Bitcoin, and I guess maybe I rebooted. Nope, I rebooted since then. So I'm going to create the screen again, and now I'm in here. And so now I'm just going to run, go up directory and just run source Bitcoin D, and that's going to kick that off. Then since this is running a screen, I can detach, Control A D, and we can sort of see what's going on here. So Bitcoin D is running. It's going to do its thing. It's going to start syncing the blockchain, pulling everything down, and we can use the PDF tool to just sort of watch the hard drive get bigger. So right now it's only using about 1.2 gigs, and so we'll see that start climbing up as it starts pulling data down. Last time I did this on Raspberry Pi 4, it took 28 hours to sync, so that was running on Ubuntu, and so we'll see how this does with this setup. But that's basically it. Once this gets up and running, you're good to go, and your blockchain will be synced in about a day. So that should be it. So one last note, just to recap what we did here. So we built the Raspberry Pi, put it together. We went and we installed the latest 64-bit OS of Raspberry Pi OS onto the SD card. We flashed it. We installed it. We got it running. We had to set a few sort of initial variables like the password and turning on SSH. Then we were able to get into there through the command line SSH from my laptop, and from there we set some stuff up, we installed some tools, and we went in here and we got the latest code. We pulled down the version tag that we wanted, and then we started building. And the main thing there was we have to install some initial tools for building. And since we're on the Raspberry Pi, we built everything else from source. So these are the tools that are needed to run the build. You need things like Automake and Python, all that sort of stuff. And then we went under the depends folder. We ran the make there. And so that built all of the dependencies. That includes things like the Berkeley DB, all the other boost libraries, things like that. We did build it with full support for UI, Qt, QR codes, all that stuff got built with this mode of doing it. Once we built the dependencies, we had to come in and sort of follow this. So we run the Autogen with the configure. You need to pass it the flag to tell it where to look for all the dependencies. And after that, we ran make, which took a while. And then I couldn't get make install to work, but figured it out anyways. And so then we got up and running. So that was about it. Not too bad, a couple hours of work. And as you saw, I've installed Bitcoin a few different ways, a few different times. And every time I run into a few dead ends where I screw stuff up and have to restart something. But if I can do it, you can do it. So let me know if you have any questions.